All right, guys, welcome back. This is going to be the third and final part to the 8.1 instructional video. And really what you've experienced so far is kind of the setting of the scene, so to speak. We've looked at one video from Khan Academy, which introduced the idea of negative exponents. You saw the part 2 video possibly, which dug more into the theory of why do we treat negative exponents the way we do? Why are negative exponents often fractions? How do we solve them differently than we do positive exponents, and what's the relationship there? And that dug into the theory, the intuition behind that. So either way, you've seen to this point the idea, the mathematical concepts behind negative exponents. In this video, we're not going to dig as much into the thoughts behind it. Rather, I want this video to be all about the process. Okay, we've seen a definition for negative exponents. Let's go through some examples. Okay, again, if partly way through the video, you're like, okay, I kind of see the process, but I don't really understand where this comes from. Why are we doing what we're doing with negative exponents? I would encourage you to, number one, go back and watch the 8.1 part 1 instructional video, which is the introduction from Khan Academy. And if you really want to think deeply about why we're doing what we're doing, I would encourage you to check out the 8.1 part 2 video, where I dig more into the idea of why we solve negative exponents the way we do. But for now in this video, we're just going to go through some examples together. It's going to be example based. This is practically what I need you to do to solve problems. And so we will start with 4 to the negative third power. And what we know about exponents from our previous videos is that instead of something like 4 to the third, where that tells us we're going to multiply 4 threes together, negative exponents tell us the opposite. Negative exponents tell us the opposite. What they tell us is we are going to multiply by 1/4, or we're going to have 3 1/4 multiplied together in this case, or we're going to divide by 4 3 times. So what we do to undo negative exponents, or rather not undo them, that's not the correct term, but to get rid of the negative exponents and replace them with positive exponents, is we write them as fractions under 1. We write them as fractions under 1. By taking 4 to the negative third and putting it in the denominator of a fraction under 1, it gets rid of the negative exponent. And so we will quickly find out that 4 to the negative third is 1/64. Okay, again, if this idea is foreign to you or this is pretty confusing, again, I would encourage you to check out those other videos that I referenced earlier. But to get rid of the negative exponents, we put the base to the exponent in the denominator, and that makes the exponent positive. It'll no longer be negative, and then we can solve using our knowledge of exponents. So maybe I'll write out that middle steps here. In this case, we know 4 to the third is 4 times 4 times 4, which gives us 1/64. Okay, so let's look at a few more examples together. Maybe we'll start out with another simpler one. In this problem, I have 3 to the negative 4th power. 3 to the negative 4th power. What am I going to do first to figure out what 3 to the negative 4th power is? Well, I want to get rid of that negative exponent, so I will rewrite the problem as 1/3 to the 4th power. Again, by taking 3 to the negative 4th power, what that means is I am going to put the 3 to the 4th power under 1, and it will make that negative exponent turn into a positive. Okay, we move it to the denominator of a fraction. Now I can solve this. And we know, if we don't know what 3 to the 4th is off the top of our head, it's always a good idea with exponents to write out what the exponent means. And that will reveal to us what our exponent is. 3 to the 4th is just 3 multiplied by 4 times, or 3 multiplied. We have 4 3's multiplied together. And that will give us 1/81. Again, 3 times 3 is 9. 3 times 3 is 9. So we have 9 times 9, again, giving us 1 over 81. So broadly speaking, the way I solve negative exponents, I move them to the denominator of a fraction with 1 on top. That will make the exponent positive, and I solve from there, just like I traditionally learned with exponents. So maybe let's get into a couple more, or maybe we get into a little bit more complexity here. -3 to the -2nd and -3 to the -2nd. Okay, what do negative exponents look like when not only is the exponent negative, but the base is negative as well? And what you're going to encounter are two different scenarios. You can see what looks like almost the same exact problem here, but we're going to solve it a little bit differently. Let's first look at the first one. And while it looks confusing, the steps are going to be pretty much the same, okay? I'm going to get rid of the negative exponent by putting it as a fraction under 1, or moving everything to the denominator of a fraction with 1 in the numerator. And that will make my exponent positive. And please notice the negative does not disappear off of the 3. Okay? What we're saying here is the quantity -3 is going to the -2nd power. The negative doesn't disappear. The only negative that goes away when you move this value to the denominator of a fraction is the negative exponent becomes positive. The negative exponent becomes positive here. Because all we're really doing is rewriting it. We're rewriting it in a different format. Okay, so we lose the negative exponent, or we get rid of it by moving that to the denominator of the fraction. But now we're going to think about, okay, what does -3 squared mean? And again, if you struggle with this, I would encourage you to really hone in, really focus on what the meaning of an exponent is. What does the quantity -3 squared mean? Well, what it means is the value -3 is multiplied twice. Excuse me. -3 is multiplied twice. Okay, we have -3 times -3. Again, -3 squared in parentheses might be confusing, but if we know what it means, we write it out and we quickly see that our answer is 1/9. -3 to the -2nd is 1/9. Okay, well, what about this version here below that's written slightly differently? Well, I think the first thing to do is to notice the difference, right? We don't have parentheses in this case. And in order to understand how this will affect our solving of the problem, we must understand what parentheses do. Parentheses are barriers, okay? They group together quantities, okay? They include them together. It's like when you were in gym in elementary school and you and your best friend wanted to be on the same dodgeball team. And so you told your gym teacher, hey, we're a package deal. What did you mean by that? You meant, I don't care what team we're going, but we're going together. That's kind of what parentheses do. In this first example, the parentheses take the negative and the 3 and make them a package deal and say, hey, if one of us is going to be put to the -2nd power, both of us are. But without the parentheses, okay, we no longer have that package deal. Without the parentheses, the only thing that is applied to the -2nd power is the base that is, or the value, the base that is directly below and to the left of it. Only the 3 in this case is being applied to the -2nd power. Whereas the parentheses take the negative and the 3 and apply them to the -2nd power in the previous example. So how does that shake things up? Well, again, we are going to get rid of that negative exponent by moving the 3 in the exponent to the denominator, and that will make that 2 become a positive. But notice the negative didn't really tag along. We could write it in the bottom, but we could also write it in the top. And really what you could imagine here is when we see a negative out in front of a number like this, it's almost like -1 is being multiplied by 3 to the -2nd. Okay? Only this 3 is to the -2nd power. The negative is not. Again, how's that going to change things? Well, now when I look at what my exponent means, it's not -3 times -3. No, because the negative is not in the denominator to the second. It could be in the denominator, but it is not to the second power like the 3 is. And so what we really have going on here is negative, and then we have 1 over 3 times 3. What is that going to leave us with? That will leave us with -1/9. It will leave us with -1/9. Okay? So again, the difference here is because the parentheses are not there, only the 3 is being applied to the exponent. Here we have the whole quantity -3 being squared. It's being squared in the denominator because our initial problem was -3 to the -2. But here, only the 3 is going to get squared. The negative will not be squared because it is not included with parentheses. And when we don't have parentheses, the only thing that is the base being applied to the exponent is the number directly below and to the left of the exponent. Okay? So hopefully you see the difference there. And again, it can have major consequences. One of our answers being negative, one being positive. Let's do a couple more examples. Let's look at -7 to the 0 power, -7 to the 0 power, and -4 to the -3 power. Okay? And this will be a great check for yourself where you can go, hey, how am I doing with negative exponents? I would encourage you to try these on your own, see how well you are understanding them, and then we'll kind of go from there. So hopefully you paused the video and gave them a shot. Now you can check your work with mine. Let's start with the top one and look at what's happening in this situation. Well, I don't have any negative exponents present, so I'm not going to put anything in the denominator. What I do have present, though, is I have the quantity -7 being put to the 0 power. The quantity -7 being put to the 0 power. So what is anything to the 0 power? Well, it is 1, and that will be our solution. The quantity -7, the number -7, is put to the 0 power, and so, consequently, we end up with an answer of 1. And again, you can learn more about that in the previous videos where we discuss how all exponents to the 0 power are 1. Now, what's different about the second one? Well, the second one, we don't have parentheses. So how does this shake things up? Well, really how you could rewrite this, and maybe this will be helpful for some of you, you can almost imagine this as -1 times 7 to the 0 power. Okay? It looks like -7, but really what's happening is -1 times 7 to the 0 power. And how are we going to see this illustrated? Well, we don't have the parenthesis grouping the negative and the 7 together. And as we just learned, that means only the 7 is being applied to the exponent. Unlike in the previous where it was -7 to the 0, we don't have the parentheses there. So really we're looking at 7 to the 0 power, which we know is 1. And so I have this negative, and really again, maybe it's helpful to imagine it's -1 times 7. Really what's happening is that 7 to the 0, of course, is going to be 1. And so my solution will come out to be -1. Because if we view this as -1 times 7 to the 0 power, we do 7 to the 0 because exponents come before multiplication in the order of operations. And we end up with -1 times 1, which gives us -1. Now you may be wondering, Mr. Carter, why did we not look at it as -1 times 7 in the example above? And that's a great question because there are parentheses there, which indicates to us mathematically that we are taking the physical number -7, as in between -6 and -8, that number -7 is being taken to the 0 power. Because we don't have parentheses there, that's not what is happening here in this second case, which is why we can view it almost as -1 times 7 to the 0 power. Okay? So again, hopefully you're seeing if there are no parentheses, the only thing being applied to the exponent is the number directly to the left and below it. That is the only number that is considered the base when we don't have parentheses. Okay? We look at this final one here, -4 to the -3rd power. Unlike the previous examples, we do have a negative exponent here. So how are we going to solve this? Well, we know we can rewrite this as 1 over -4 to the 3rd power. Okay, by writing that in the denominator, it gets rid of our negative exponent. And then again, we're just going to think about what does -4 to the 3rd power mean? Well, it means we have -4 multiplied. We have 3 -4s multiplied together. And again, we know -4 times -4 would be +16. And 16 times -4, that would give us -1 over 64. You could also think about this as 1 over -64. They're the same thing. So broadly speaking, hopefully these initial integer numerical examples make sense on applying negative exponents and solving them. Again, the broad rule: to get rid of negative exponents, we rewrite them as positive exponents in the denominator of a fraction with 1 on the top. The other big rule we've covered is unless there are parentheses present, the only thing applied to the exponent is the number directly below and to the left of it. Okay? But it would not be algebra if we just stopped there. It would not be algebra, because in algebra we really introduce variables and working with variables. And so we're not going to stop with just working with numbers and negative exponents, but we're going to work through examples with variables. And so let's see what that looks like. Let's say I have 4yx to the -3rd. 4yx to the -3rd. Okay? And what I want to do is I want to do something called simplifying, and I want to simplify this exponent. Now notice I'm not using the word solve, and I'm not using the word evaluate. Why? Because I don't know any values for y and for x. And if I don't know any values for them, numerical values such as x is 2 and y is 7, then I'm not going to be able to solve or evaluate this where I end up with some specific number. We will get to problems where we do that in a bit, but for now, I'm just trying to simplify this. And what does simplifying imply? Well, it implies I get rid of the negative exponents. In other words, I can't make this look any nicer or neater, okay? And in math, what we want to do with simplification, we don't want negative exponents. We want to simplify fractions as much as possible, okay? And really, we want to clean it up, okay? Just like the logic used in simplifying fractions in middle school, we're going to kind of apply that here. So without further ado, let's solve the problem. But in order to solve it, let's understand what's happening here. What do I mean by 4yx to the -3rd? Well, when numbers are just next to each other and there isn't an indicated operation in between, what we can assume is that they are being multiplied together. So really what this says is I have 4 times y times x to the -3rd. Okay, and I could rewrite these in any order that I wanted with the commutative property, but it's really important we understand that these are all being multiplied together. 4 times y times x to the -3rd, right? And it's the same logic we've used in previous sections, right? When we see 2x, we understand that means 2 times x, okay? 2 times x. Okay, So what are we going to do here? How are we going to simplify this? Well, I think by understanding these are multiplied together, it helps us to break this apart and understand what simplifying do we need to do. There's nothing simple or simpler or something we could make simpler with the 4, and neither is there for the y. There is a 4 and there is a y. We could look at the y as to the first power, but that would be excessive to write the 1 there. Where we do see some simplification is with this x to the negative third. Now notice I am automatically assuming that only the x is being put to the negative third power because I don't have any parentheses indicating otherwise. So how can I simplify this? Well, I simply am going to use my rule of negative exponents to rewrite it. And so I will rewrite x to the negative third as 1 over x to the third power. Okay? Now I have no more negative exponents here, but I don't want to leave my answer like this, all messy with my multiplication symbols and everything broken up. I want a nice, neat, clean expression with everything put together. And really what this gets back to is your knowledge of multiplying with fractions. Multiplying with fractions, okay? Just like we look at 2 times 3 over 2, and I would say, I would clean that up and write this as 2 times 3 over 2, or 6 over 2, and really that would become 3. I'm going to apply the same logic here. Let's multiply all of these together. Now, 4 and the y don't have denominators, but we could write them as denominators over 1. And we know with multiplying fractions that we multiply numerators by numerators, denominator by denominator. So 4 times y times 1 leaves me with 4y. And 1 times x to the third leaves me with x to the third. And so to simplify 4y, x to the negative third, I am really going to just end up with 4y over x to the third. Now this might seem like a lot of steps, and you may notice something here. You may notice, wait a minute, Mr. Carter. All you really did, through all that explaining and work, is you just moved the x to the denominator to the other side of the fraction, right? If we view this whole thing as a fraction over 1, all you did is move the x to the denominator because it had a negative exponent, and you left the 4 times y in the numerator, and you'd be absolutely right. And the shortcut would be to jump straight here. When you're working with negative exponents, if you want to kind of jump the gun, take a shortcut, broadly speaking, and this won't apply in every algebraic situation ever. You'll learn about some in Algebra 2 where maybe this doesn't quite apply as simple. But for our purposes, we can just flip the side of the fraction that the negative exponent is on and call it a day. Maybe another example will help illustrate this principle better. Let's say I had 1 over w to the negative fourth, and I want to simplify this. Well, what do I need to do? Well, really I only have the 1 and I have the w to the negative fourth, and I can't simplify the 1 any further. But I can simplify negative exponents, and so I follow my rule, and I take my negative exponent, and I rewrite it as a positive exponent in the denominator of a fraction with 1 on top. And now I look at this, and while I have gotten rid of the negative exponent, it does look somewhat messy. So I want to clean this up a bit. Again, we're simplifying. We want this to look nice and neat and simple. And so what am I going to do? Well, what's happening here is a division by fractions. I am taking 1, what's happening in our brain here, I am taking 1 and I am dividing it by 1 over w to the fourth. And we've learned in previous lessons in instruction, when dividing fractions, we don't ask why. Instead, we don't divide. We flip the second and multiply. That's our little phrase. What do I mean by that? I mean, instead of dividing fractions here, I'm going to multiply by the reciprocal of the denominator. When dividing fractions, don't ask why. Flip the second, flip the denominator, and multiply. So we do that, we apply that logic, and I end up with 1 times w to the 4th over 1, which if we write 1 as a fraction, 1 over 1, and I multiply the numerators and denominators, I end up with w to the 4th over 1, which we all know is just w to the 4th. Again, a lot of work, a lot of steps, a lot of cleaning up, but we could just make the transition off the bat, take a little shortcut. Again, if we recognize all you really need to do with negative exponents is flip the side of the fraction they're on. I have a negative exponent in my denominator here. How can I simplify it? Move it to the numerator and it will become the positive exponent. Again, it doesn't look like there's a numerator here, but any whole value we can write as a fraction over 1. So I take my w to the negative 4th, I pop it up in the numerator. That leaves me with a 1 in the denominator. 1 times w to the 4th is just w to the 4th, and we are out of there. With negative exponents, we can just flip the side of the fraction they are. If they're in the numerator, move them to the denominator. If they're in the denominator, move them to the numerator. Again, does that mean our traditional rule no longer applies or just flew out the window? No, rather this idea of flipping the negative exponents to just the other side of the fraction comes out of it. It's just a little shortcut we can take. So let's dive into a few more examples. Let's say I have 3m squared t to the negative second, but in this case, I know that m equals 2 and t equals negative 3. Now, instead of simplifying, I'm going to do what's called, and you've heard me use this word a lot in the past, solving or evaluating is another word we would use here. I am no longer just going to simplify the algebraic expression we see here on the left, but what I'm going to do is I'm going to evaluate it. I'm going to get an answer that is a number. It could be a fraction, it could be decimal, it could be a whole value, but I'm going to get a number because I know what the variables are. My recommendation, though, treat this as if these guys are not there. What do I mean by these guys? I mean m equals 2 and t equals negative 3. Let's pretend we don't know that. Go ahead and simplify the expression, then plug our values in. And I think that'll be a little easier. Could you go the other way and plug your values in right away and then simplify it? You could, but I find more people tend to mess up that way. So let's apply the shortcut that we've been discussing, flipping sides of the fraction. You might go, Mr. Carter, I don't see a fraction here. Well, similar to in math, when you see 4, you don't see a fraction. You know from middle school when we've learned about these things that really any whole number or any integer can be written as a fraction over 1, right? 4 is 4 over 1, or 4 divided by 1. And we could apply the same logic here, right? In our brain, we can imagine this, since there is no visible fraction, this is all the top, what our algebraic expression is the numerator, and on the denominator we have 1. So, why is that helpful? Well, to use my little shortcut, 3 does not have a negative exponent, right? We imagine all 3 of these things multiplied together. 3 times m squared times t to the negative second. 3 does not have a negative exponent. M does not have a negative exponent, but t does. How are we going to get rid of that negative exponent? We will rewrite this, but t will pop down to the denominator, and that will make the exponent positive, okay? So how do we simplify? We rewrite this to get rid of the negative exponent, so t will jump down to the denominator and become t squared instead of t to the negative second. And now we are good to go ahead and plug in our values. How do I know that? Because there's no other simplification left, right? I can't make this any simpler. I have no more negative exponents. There's no more simplifying I can do. So I go ahead and plug in my values. I'm going to plug in 2 for m, and I'm going to plug in negative 3 for t. And notice I'm plugging them in using parentheses. This is incredibly important, especially when we're plugging in negative numbers like negative 3 here. And they go in parentheses because when we see t is being squared, that means the whole quantity t is being squared. So if -3 is going to go in for t, then -3 itself needs to be squared. If we do not put the parentheses there, that negative, remember, will get left out, and really the only thing we're going to square is the number 3. But that's not what t says. T says, hey, I'm -3, t is equal to -3, and so if t is being squared, then the whole quantity, -3, needs to be squared. So to be safe, if that doesn't make a ton of sense to you, always plug your numbers in when you're evaluating with parentheses. Now remember, before we ever multiply here, right, we have 3 being multiplied by the 2 squared on the top. Before we ever multiply, remember, according to our order of operations, exponents come first. So I do 2 squared, which is 2 times 2, which is 4. And -3 squared, which is -3 times -3, will be positive 9. Now I can do my multiplication, and I get 12 over 9, which can be simplified down to 4 over 3, since 12 and 9 are both divisible by 3. And so what you can see here is the same rules of negative exponents and working with parentheses are still applying. We're just getting a little bit more complex and doing a little bit more each time. So let's look at another example together. Rather, we'll do 2 more examples like this. And again, I would encourage you to pause the video. And once I write the problem down, try these on your own and then check your work with mine. Really give yourself an honest evaluation, see how you were doing with these types of problems. And we are going to evaluate both of these algebraic expressions under the assumption that n is -2 and w is equal to 5. Again, pause the video and get these a shot on your own. If you are sitting there, though, and you're going, Mr. Carter, I'm so lost. I have no idea what's going on. I would recommend you pause the video and you email me. Say, hey, I'm super lost. I need some help. I'm not getting this, so that we could maybe meet one-on-one or schedule a one-on-one session for me to help you. So hopefully you've solved it. Now check your work with mine. Again, what I want to do here is I want to evaluate these algebraic expressions given the values n equals -2 and w equals 5. But before I evaluate, I'm going to simplify each one. Okay? So I look at the one on the left. I'm not going to mess with the w squared. Why? Because it already has a positive exponent. And there are no coefficients to simplify, but n has a negative exponent, so I need to simplify it. Again, I think the easiest way to do this, the shortcut, so to speak, is to get rid of that negative exponent. We're going to move n, our friend n, down to the denominator. That will make its exponent positive because it has flipped the side of fraction it's on. Again, if that doesn't make sense why we're doing that, let me know via an email and I can show you the full hand-blown work. But our shortcut says you flip the side of the fraction, the negative exponent is on, and it will make that exponent positive. Okay? So we do that, and with nothing left on the top, it'll be just a 1. So we'll have 1 over n to the first times w squared. Now I'm in a place where I can plug my values in. How do I know to go ahead and plug them in? Because I'm now in the simplest form I can get. There are no other negative exponents to get rid of. And again, in evaluating here, order of operations says, hey, handle exponents first before I multiply these 2 quantities in the denominator together. -2 to the first power will be -2. And 5 squared will be 25. And so this evaluates out to be, the solution will be -1 over 50. -1 over 50. Let me write that a little bit neater. -1 over 50. Okay. Again, things to remember. Notice that when I plug my values in for n and w, I plug them in with parentheses. This ensures I make no mistakes when distributing my exponents, especially when messing with negatives. Okay, or evaluating my exponents, not distributing. So what are we doing over here with n to the -3rd times w to the 0 power? Well, again, I'm going to simplify before I plug in my values. I need to get rid of that negative exponent. And so how do I get rid of negative? I'm going to move it to the other side of the fraction. And maybe you go, I don't see a fraction here. Well, just like when you see the number 4, we know that really 4 over 1 is how we could write it as a fraction. So we could imagine this as n to the -3rd, w to the 0 over 1. And so I'm going to move the n to the -3rd to the denominator to make that exponent positive. That'll leave me with w to the 0 over n to the 3rd power. Now, if you want, you could simplify w to the 0 here, but maybe that's a little confusing. So let's go ahead and plug in our values. And when we plug in our values, I get 5 to the 0 power over -2 to the 3rd power. Well, anything to the 0 power is just 1. And you might not know what -2 to the 3rd power is off the top of your head, so I'd encourage you to write it out. It's 3 -2's multiplied together. -2 times -2 is +4, times -2 will give us -8. And so n to the -3rd times w to the 0 power evaluates out to be 1 over -8 when n equals -2 and w equals 5. Let's look through one more example together, a word problem, just to make sure we're really getting this. A biologist is studying green peach aphids. In the lab, the population doubles every single week. The expression 1,000 times 2 to the w models an initial population of 1,000 after w weeks of growth. We have 3 questions we want to answer. What is w equals 0? What does that represent? And we want to answer the same question for w equals 3 and w equals -3. Well, first let's look at our algebraic expression and what's going on here. They tell us 1,000 times t, or 1,000 times 2 to the w models an initial population of 1,000 after w weeks of growth. Okay? Really what this function is looking at is the population is doubling every week. So we can imagine at this moment in time, here today, we have 1,000 green peach aphids. And they are doubling, they are going to double every single week. The expression 1,000 times 2w models this, starting with 1,000 and the w weeks of growth. Okay, so let's dive into this together. Let's first look at what w equals 0 represents. Well, again, as we've been doing with evaluating, we are going to simply plug in 0 for the w. And we can go ahead and jump right into this because there's no simplifying necessary. No simplifying necessary because we don't see any negative exponents or anything like that. Now, be careful. The temptation will be to go, oh, 1,000 times 2, 2,000. But remember, we have to work through our exponents before we handle our multiplication according to the order of operations. So here I'm going to handle 2 to the 0 before I do 1,000. So this will be 1,000 times 2 to the 0 is 1. And I end up with 1,000. And again, let's interpret our answer. What does that represent? Well, if this expression is helping model the population doubling every week, if that's the situation that's happening, what this expression, or what our result will be, is if w is the amount of weeks that have passed, then this, 1,000, is our population. And this should make sense, right? They tell us, hey, in the lab, you've got 1,000 green peach aphids, okay? No time has passed. No weeks have gone by. That's what it means when you plug in 0 for w. No time has passed. No weeks have gone by. You still have 1,000 green peach aphids. which is what we had with this function. So now let's look at w equals 3. And again, we apply the same logic. Go ahead and plug in 3 for w. And this time we are going to get 1,000 times 2 to the, or 8, 1,000 times 8, because 2 to the 3, 2 times 2 times 2 is 8. And we get 8,000. And again, what would our interpretation be? Well, if our expression models the population, then what we see here is we have a population of 8,000 green peach aphids after 3 weeks have gone by, right? If we look at 1,000 times 2w, we have currently 1,000 green peach aphids. They're doubling every week. So every week that goes by, we multiply by 2 more. So we have 2 to the w. So 2 to the third power multiplied by my initial 1,000 tells us that after 3 weeks go by, if you keep doubling, if you start with 1,000, in 3 weeks you have 8,000 green peach aphids. The last one we'll look at is w equals -3. When we go ahead and plug that in. And in this case, we have a little bit more simplification we need to do. To get rid of the negative exponent, we move it to the denominator. The 2 to the -3rd will be moved to the denominator and become 2 to the +3rd. Okay? And that leaves us with 1,000 over 8. And that, 1,000 divided by 8, equals 125. And now let's think about what this interpretation would mean. And it could be different, right? What we're looking at here is, you might argue, Mr. Carter, w equals -3. Hey, you can't go back in time. That's weird. And what I think we're imagining in this problem is, right, we're not assuming that all at once, we had 1,000 green peach aphids just dropped at the lab. In that case, right, then we couldn't go back in time. But maybe this idea of the green peach aphids doubling has been occurring over time, and 1,000 is when we just started really looking at this. At this moment in time, we have 1,000. And if we think about it in that context, right, they've been doubling in the lab, and we currently have 1,000 green peach aphids. What would w equals -3 represent? Well, that would represent 3 weeks prior. And again, that assumes that we've been doubling in the lab for a while now. And at this current moment, while we're measuring, we have 1,000. So 3 weeks prior, if they had been doubling, we would have only had 125. Okay? Again, can get a little fuzzy with the interpretation there, but again, we'll assume that we've been doubling in the lab for a while. At this moment, we have 1,000. And so based on our measurements, if we've been doubling for a while, and at this moment we had 1,000, that would mean 3 weeks ago, 3 weeks prior, we would have only had 125. 3 weeks from now, we will have 8,000, and at the current moment, we have 1,000. Guys, I know this was a bit lengthy, but I really appreciate you watching. Let me know what questions you have, and hopefully you feel a little bit clearer about solving problems involving negative exponents.